Huh. Hello, everyone, and welcome back to the 2018 Hack Summit. We're here with Antonio Salazar Cardozo from the Keep Network, and the Keep Network is an exciting project which is a privacy layer for the Ethereum chain. It's an off-chain container for private data, which helps you basically to harness the full power of the blockchain in a private way with your data in integrity. So, Antonio, thank you so much for being here. We're excited to learn more about your project and to teach us everything you can in the window we have today. So thanks again, Antonio.
Thank you. I'm actually going to talk just a little bit about the project at the beginning, but I'm mostly going to be focused on how we build projects in this kind of slightly different environment that we exist in as developers on public blockchains. There are a few assumptions that I think I at least carried in from previous jobs in sort of the web space that don't really apply the same way in the blockchain space. And so, I'm going to talk a little bit about what we can learn from the past and carry forward and how we can update it for the world that we live in. So let me share my screen really quick. A little slide support. And can you see that all right?
Yep, looks great.
Perfect. All right. So, like I said, the basic premise of this presentation is how do we build software in this fast-moving ecosystem? Tony, I'm the tech lead at Keep Network, and I've been programming for probably 15 years now. And I came out of college a little over 10 years ago, and so for me, in the beginning, like when I first really started professionally doing software development, there was continuous delivery. That was sort of the buzzword. We were just discovering how to do it. We were figuring out that you could move fast and break things in the Facebook invocation of this particular concept, and that you could get out there and push code so quickly that even if you pushed out a bug, you could fix it overnight or over a minute. So you could get that fix out there so quickly that your users didn't have to notice, or you'd have 5 users out of 100 million who would notice, and then you could get it fixed before anything else happened. And key aspect of this was that this continuous delivery was on your own infrastructure. So Facebook owned the computers that it pushed its code out onto. Immediately after that, we started seeing the rise of cloud platforms. And they, in a lot of ways, enabled this for everyone else. So even though it wasn't your own infrastructure in the sense that you had a box in the room next door or in a data center that you owned, it was still, you pulled down, you pushed up your code rather, and you deployed it into the cloud, and it rolled out to everyone. So it was your own infrastructure in the sense that you controlled firing things up, shutting them down, pushing code, all that stuff. The world that we're in now is decentralized delivery. And I think, to me, the biggest shift that has introduced in the way that I think about how we develop is that it's on everybody else's infrastructure. So, your infrastructure is easy. Everyone else's infrastructure is really hard. And the reason is your infrastructure, you can just fire off a signal that winds its way through the cloud or through your data center or whatever, and your code gets pushed out. You do a blue-green deploy, you just shut everything down and spin up new instances, however you choose to do that deployment, your code is out there as soon as you want it to be, pretty much. Everyone else's infrastructure means the best thing that you can really do is raise your hand and say, hey, there's an update, and then hope that everyone updates what they have locally, and that the update takes, and that you didn't miss something because they had a hardware configuration that you weren't expecting, or a network situation that they weren't expecting, or what have you. So you give up a lot of control by operating on everyone else's infrastructure. And that means that you have to be a little more careful about how you develop your software. So the good news is this isn't new. This problem isn't new. And a lot of us, I think, are fairly young, not everyone, I'm sure, from a software development standpoint. And so, like me, we came to it right around when continuous delivery was becoming a thing, and it was sort of, that was the way that you did software development, because most software was more and more being built on the web and was able to make use of continuous deployment. And so you thought about not only architecture through this lens, you thought about the actual process of developing through this lens. So you could afford to say, we're going to make our iterations extremely short. We're going to do very little planning ahead of time for what's a year down the line. We're just going to think about what we need to get done this week. And then if we need to make a tweak in 3 weeks, we'll just refactor, deploy the refactored stuff, and we're fine. Everything's okay. And if we mess something up, again, we can fix it in 5 minutes. My sort of anecdote for this way of thinking is, when I was a kid, I would work with my dad on, just little chores around the house, like fixing a door or whatever. And I have always had the sort of continuous delivery mindset. So I would immediately reach for the screwdriver or the hammer or whatever, basically the nearest tool to go after the problem. And my dad would, without fail, have to stop me and say, listen, stick your hands in your pockets and think for a minute, right? If we mess this up, if you hit the hammer on the wrong thing and you bend a piece of metal the wrong way, or you leave a hole in the wrong place, this door is just busted. Like you've screwed it up completely. Stick your hands in your pockets and think for a minute about what you're going to do, what your goal is, how you're going to go about achieving this goal. And then when you actually start doing it, we can make sure that we don't leave a broken door behind, or a door that's fixed in the original way but broken in a different way. So the problem isn't new. My dad's an electrical engineer. I was a software developer. So, that's sort of the mind shift, is the people who work in the physical world, in the physical space, have to deal with this problem. And in fact, people who did software before continuous delivery also had to deal with this problem. So one of the people on our team was building software when building software was, I hand you an installation disk, or I come to your company and install this thing on your stuff, on your infrastructure, on your computers, and then I go home, and if something goes wrong, I have to come back out. So these are not new problems. We just have to kind of take a step back, look back at a lot of the way that we did things, and think about, okay, how can we tweak the approaches to some extent that existed then and update them with some of the learning that we've done in this world of continuous delivery. So I'm going to break this down into 3 sort of high-level guides that I've been following over the past 9 months as we've been running with Keep and really building out our code base. The first one is, you have to plan. This is my least favorite because I love, as I said earlier, just kind of grabbing the hammer and going after it. But you have to do some planning ahead of time. So first of all, you have to take that big idea that you wrote your white paper about, that you may even have written a yellow paper about, and take it from this high level, we know how all of the moving parts interact with each other and how everything is meant to, and break it down into, what are the bits of it? Like, what are the individual components that will coordinate to get this done? Through that process, you kind of start to find the edges of your system. And the reason that I say your system is because you've got the overall system. So if you're working on Ethereum, it's your application plus the Ethereum network plus whatever else it is that you pull in, be it, in our case, for example, we've got a libp2p network that we create with our nodes. So libp2p is one of the edges of our system. And we have to know that that's an edge, right? Like, we stop worrying, or rather we hand off worry to the other side of that edge when we hit the network layer, or when we hit the blockchain layer. So we figure out how they interact, and when we figure out how they interact, we can think about what those interfaces look like, how these things talk to each other, what the minimal set of functionality that we need from the chain is, what the minimal set of functionality that we need from the network is. And once we do that, we can codify them into actual, code interfaces. In our case, it's Go. In someone else's case, it might be Java. Haskell, whatever, but you can define these are the functions that we expect. This is how we expect to interact with the chain. This is how we expect to interact with the network. The last thing is a little more specific, which is pin your dependencies. So all of these libraries that you use, in our case, again, I'm going to go back to the example of libp2p, but Ethereum is the same way. Geth has a new release every few weeks. libp2p just went through a major refactor. So we have to be able to make sure that while we're building our stuff, we can rely on our dependencies staying still until we're ready to upgrade them. So make sure to do a little bit of pinning, maybe even clone the repositories, which is what we do, and make sure that that code remains unchanged until you're ready to pull in those changes. The second phase or piece is to prototype. Prototype, prototype, prototype. So the prototype really comes from this almost writing idea of writing a rough draft first. You want to start with your idea, and then instead of going into, okay, let me architect this and build it all out in my brain and draw it all out on paper and diagram it all out in Google Docs and then start writing everything, you want to give yourself an opportunity to make sure that you find the weird little stuff in all of the technologies that you use. Be it a third-party library, or again, the way that your computer talks to the network might be a thing that that behaves a little bit differently. Finding out things like block times and how those affect what you're trying to do. You can do all of those in a prototype. You can be ready to throw it away. So when you build a prototype, the idea isn't, I'm going to write phenomenal code. It's, I'm going to hack out some code, kind of put the idea that I'm thinking onto this code base, run it, see if everything works the way I expect it to, figure out what doesn't work the way I expect it to, and inform the way that I'm going to build my final product. Lastly, it gives you an opportunity to learn your libraries. So this is, again, about finding those weird edges, finding those weird bugs, figuring out that, hey, this library looks type safe but isn't. I can hand it garbage and it won't fail until way down the line. All of these things are things that you really kind of need to know as you plan the way that you're going to build your application. But a lot of times we don't figure it out until we get halfway into building it. Getting a prototype done means you can kind of ignore all of your best practices. You can kind of build out your whole system almost very quickly without worrying about commit messages or commit history or whether your file is 5,000 lines long. It doesn't matter. It's just like, let me get something working. The last step is automate. So this is after you've built your prototype, you've planned out your thing, you're building your application, and you want to automate all of the stuff that is going to get in your way. And this is really borrowed from that continuous delivery mindset, which is how can we clear as much of the garbage of development away so that we can focus on all of the practical issues that we're going to run into day to day. So you want to automate formatting. You want to automate linting. You want to automate analysis. So if you have tools that can analyze your code, that can tell you that you might have an issue that you need to check out before you kind of move forward, you can automate back to you in pull requests or what have you. This lets you catch it early. If you run into one of those issues in real life or during an audit where someone says, hey, this is something you need to look out for, and you say, we can actually look out for that in an automated way. Again, automate that analysis, make yourself catch it early. Of course, automate your tests. That's kind of self-explanatory. We've all been doing it for a long time. It predates continuous delivery, but again, it's the same idea. Make sure you don't create bugs without expecting it, and make sure that you don't recreate bugs after finding them. So the idea here is learn from the past. These are all techniques that have existed for a long time. We've, in various ways, been doing them. The limitations that exist in our realm are not really that new. They're just a little bit tweaked. They're a little bit sideways. And I think that's true across disciplines. It's not just true for the developers. So it's really, how can you learn from the past when a lot of the ease and cavalier way that we have approached development and software for the past 10, 15 years no longer applies. Or it does apply, but it applies in a little bit different way. Stick your hands in your pockets. Think about what you're doing. Don't just go after a thing. We're now playing with, real people's money, real people's data in our case, right? Real people's secrets. So it behooves us to stick our hands in our pockets and think about what's happening. Think about what we're doing. Think about how things can break. Think about how people can attack our systems, and really architect ultimately with all of these things in mind after having put all of that thought and care into it ahead of time. That's the whole presentation, and it was nice and quick, so we can take questions and discussion and what have you.
Awesome. Thank you for that presentation, Antonio. Very, very interesting. And I want to make sure the audience has a chance to understand as well the technology that you guys have created at the Keep Network. So maybe could you give us a quick overview of the problem you're trying to solve at Keep, and then your proposed solution for that problem?
Yeah, totally. I actually outran myself on that. I was going to start with that. So Keep Network kind of tackles the question of how can I operate a system that runs on the public blockchain that is decentralized when all of the data that goes onto the blockchain is, again, completely public, right? Anyone can see it. So one good example for the folks who are familiar with Bitcoin is how could I have an Ethereum smart contract operate a Bitcoin wallet? And that requires tracking private keys. And right now, I can't put those private keys on the Ethereum network because then everyone has them and everyone can operate the wallet. So the Keep network is kind of an answer to that. It creates a network of providers that are sort of interoperating with the Ethereum network to provide incentives and really kind of flesh out a whole structure to ensure that they keep data private. And what the providers do is they have these small, secure data enclaves, and I use the wrong term there because they're not hardware data components. They're just like a software container for private data. Your secrets, so let's say a private key for Bitcoin, are split over multiple providers. And you can pay more to split it over more providers. You can pay less to split it over fewer providers, just depending on the level of security that you're looking for. And then what you can do with this data is you can do the very basic stuff. So I can give someone else access to it, right? But you can also do something a lot more interesting, which is you can perform computations over that data. So we use secure multi-party computation to let you run sort of semi-arbitrary programs. It's going to start off being pretty limited, but we're going to build up to a more general programming experience that will let you use that data without anyone actually getting to see it. So in the case of, again, a Bitcoin wallet, if I want to sign a Bitcoin transaction, I can ship that Bitcoin wallet, I can ship that transaction into a Keep and say, please sign this. And those providers can sort of independently and by coordinating with each other, create a final signed transaction without any of the providers actually getting to see the private data.
And how does that actually work behind the scenes? What's the technology behind this?
So there are a couple of components. We're using libp2p to actually network the providers together. We're not actually using any existing libraries yet for the secure multi-party computation piece. We're still kind of surveying the landscape there, but it's very likely that we'll be rolling our own multi-party computation implementation. And we're actually currently using stuff that exists out there in paper form, right? So there's been some good research, especially on the problem we're focusing now, which is distributed key generation for ECDSA, which allows you to say, hey, I want to create a new key to operate a Bitcoin wallet, but I don't actually have the private key for it. Please go generate the keys for it. Please go generate that wallet for me, store it in a secure way, and then when I'm ready to operate it via smart contract or what have you, I will send that wallet some funds, and then that wallet will be able to do its thing.
Great. And is there any connection between zero-knowledge proofs and Keep?
There is. So we're going to be using zero knowledge proofs as it's actually a piece of the distributed key generation thing, but more generally, we're going to be using it to kind of ensure that the providers who are participating in the system don't reveal their data. So we can use zero knowledge proofs to make sure that everyone behaves correctly while they're doing these multi-party computations, and punish them if they don't behave correctly. So if they provide a poor share to the final result or what have you, those zero knowledge proofs allow us to say, okay, this particular player, this particular provider didn't do what they were supposed to, so we're going to take some money from them and punish them for that. And the idea behind that is saying, there's all of this, there are theoretical ways that we can achieve all of this perfectly and mathematically correctly, but they're exorbitantly slow, they're exorbitantly difficult. And so we say, how can we kind of go most of the way there and then cover the rest with a really good incentive model that makes it so that misbehaving, participating poorly, revealing secrets is expensive, even if it's not completely impossible.
Yeah, so it's almost like a probabilistic solution where you're saying the incentives are so dire for you to reveal a secret that it doesn't make financial sense to do so. And so you can pretty much rely on the system's secrecy from a practical perspective, even if it's not from a theoretical perspective.
Yep, that's exactly right. That's exactly right.
Very cool. Yeah, I like that a lot. In fact, that's kind of analogous to kind of the part of the vision that Dfinity has that we just learned about as well, their whole probabilistic algorithm, and how it's not, perfectly, theoretically possible. There could be faults in the system. But I think as a computer scientist, I can appreciate your approach because in the real world, from a practical perspective, you have to make trade-offs in life. And, like for all the computer scientists that said like P versus NP, trying to solve NP complete problems and, things taking polynomial exponential time, these days, these approximation algorithms that are good enough are what we use in the real world. And we can actually solve some of these really hard problems with approximation algorithms, which is basically what I'm hearing here. And that's fantastic.
Yeah, yeah, no, absolutely. I think, it's interesting. You talk about the fact that we have to do some of these approximations in real life. And ironically, one of the things that I think public blockchain technology sort of approaches is the question of trust. And trust is actually, in the real world, an approximation, right? Like, I don't know for a fact that you're trustworthy, but, based on my interactions with you in the past, I think it's worth trusting you, and so I'm going to go ahead and trust you. So really, it's kind of just taking that and applying it in a financial sense. And I think there's a lot of power to that idea, for sure.
That's great. We'll take one quick question from the audience, from Tim, which is a basic question here. Does Keep allow some transactions on Ethereum to be used as a pointer to keeps? So maybe you could kind of dig into that a little bit there. You can see the question if you click the Ask a Question button on the bottom of your screen.
Yeah. Okay, let me see here. I think the answer is probably yes, in the sense that Keep can act as a source of data if you want it to, or it can act, you can point someone to a Keep and tell them, hey, your data is over here. So if you think about, for example, a marketplace, right? I've got an MP3 file that contains a piece that I composed, and I want to allow people to purchase it. And I want that to happen entirely via smart contract. I don't want to be online when you send me Bitcoin to be able to give you access to that MP3 file. I can stick, say, a URL to it in a Keep. And when someone pays the smart contract the amount that it needs to be paid, it can give that address access, that account access to the Keep, and tell it, hey, you can now go ask the Keep for the URL to this MP3, and then you can get to it. So in that sense, yeah, there can absolutely be data in the Keep that you can kind of use to transport things privately. But we do, caveat emptor, consider Keep data, for now at least, containers to be fairly small. So we don't really see them being larger than a megabyte in terms of the data that they contain.
Great. And one last question from me, which is, are you planning on remaining on Ethereum for the time being? Have you ever thought about, should you explore other blockchains in addition to Ethereum?
We're definitely keeping the door open. So for example, with what I was saying earlier, the planning phase for us includes how can we do this in a way that doesn't necessarily mean we're 100% tied to Ethereum. And so we've architected to be able to by sort of defining our interfaces to the chain in a very specific way. But currently we're focused on deploying our stuff on Ethereum, and that's sort of, we're gung-ho 100% pursuing that piece.
That's great to hear. So how can our audience get involved if they want to learn more or work with you or use your technology? What are next steps for our audience?
Yeah, so if you go to keep.network, that's the URL. It's got a link to the white paper. It's got some other information, but you can also sign up for our Slack and our email list. Our Slack has actually been closed for a couple of months while we get our security situation in order, but we will be opening it up over the next few weeks, I believe is the current plan. And so if you go on there and sign up for the list, you'll get an email when that happens. The Slack community is, it's a good community. We do our best to keep it very, very on topic. We kind of focus on the technical, interested in people who are wanting to build applications on top of Keep, people who are wanting to, participate in the Keep network, so stake and run providers. And so we keep the conversation really focused on that and on just how we build really cool stuff with the technology that we've got.
That's awesome. Well, Antonio, it's been a pleasure having you here. I appreciate your patience with our slight delay in our schedule. But you taught me a lot, and our audience as well, about privacy as well as all the other concepts you talked about. So I just want to acknowledge you for being here, taking a stand for important nonprofits in the coding space. And I want to thank Keep Network for being a great supporter of Hack Summit and of these coding nonprofits. So thanks again, Antonio.
Thank you. I really appreciate it.
Great. So audience, we're going to be right back here with Jack O'Halloran, who is the CEO of Scale Labs, and he'll be talking all about his technologies. We'll be right back in just a second.